Greetings, Kerbal Nauts. We're doing another test. This will be the last one that I video. Don't want them to get too boring for you. Yeah, this is an SSTO test. I want to see if I can get this into orbit. Now, modification from the last time. A little bit of tweaking on the landing gear still, but if you notice, it hasn't been uploaded yet. Apologies. But on the emergency safety system test, the pods at the top got stuck on the around here somewhere. So I've put a truss segment in at the back, as you can see there, on an angle, so it acts as a ramp, and hopefully it will make them slide off. So I'm going to try and get this into orbit. So this may well be a rather boring, tedious video. My apologies. I will try and talk about something and keep it not so boring, when I'm not adjusting my attitude and making sure I don't stall. It looks about right. Other changes are these pods. I've changed the air intake. You'll notice these are the air intakes from B9's aerospace pack. Suck up the gear. Certain mods, such as Interstellar and B9's Aerospace, I'm importing some of the models and using them. They might not be the original uses that they were used for in those mods, but I'm using them for other stuff. What I'm not doing is using the extra code, the DLLs that come with them. Simple reason being that, well, something this big is 300 parts, I think, 400 parts, something like that. Some of my very, very, very large rockets have quite a few parts on them, and as you can see already, it's touching on the yellow for the simulation. Current record speed is between 10 and 12 frames per second. So if I use the Interstellar mod, that would, for this, drop to probably about 6, maybe 7 frames a second. It adds a lot of extra calculations on, and it really slows it down. So for me personally, adding in all the stuff from Interstellar and all the stuff from B9 would just kill the game. As fun as it would be, it would just kill the game. So what I decided to do is to grab the two mods, import some of the models, and make the models do what I think is realistic, but using only the functions that are currently available in the game. So, for example, Interstellar has heating effects for waste heat. Don't have that, but thermal energy is created. That just uses the internal modules for resource generation, I think it's called. So simply enough, you're just converting one resource into another at specific rates, or several resources into several resources, which is simple enough. I do have the TAC fuel balancer installed. I was testing it out and quite liked it. Didn't seem to slow the game down hardly any, didn't notice any change really, so I was quite happy to install that in full. TAC life support I installed, again didn't seem to slow the game down any, so I went, what the hell, and just installed it. I've got Kerbal attachment system installed. Again, didn't seem to slow the game down any when I installed it, so I went ahead and put it in this one, which is my live game. So I was quite happy to install those three. They are lightweight in themselves. The coding seems to be pretty decent, so why not, basically. But yeah, Interstellar, got a lot of stuff in it, makes the game fun. But it does seem to slow the game down, which is my only criticism for it, really. But then again, I'm not really surprised that it slows the game down because of all the features that it adds in. So yeah, I can't criticise it too much. Why do I have a sneaky suspicion this is under-throttled, underpowered? Anyway, as you notice on here, I've got 4 standard turbofans and 4 Rapier engines. Rapier engines should be set to manual switching, so they won't automatically switch away. What I found with using multiple Rapier engines is it will allocate air intake to one, and then the next one, and then the next one, and if it doesn't have enough for the last one or the last couple, then the last couple get depleted. It will allocate what it's got left. Excuse me. Which means if you have them, say, spread out over a flying wing, and you go from left to right, then the right-hand wing would not have any thrust and it would just spin out of control. So what I decided to do is set it to manual switching, so that I can watch the thrust from each of the engines, work out which one's going to drop out, because the thrust will start backing off, and then at a certain point I can just switch all the Rapier engines to rocket mode, which will then free up air intake for the turbofans, and the turbofans will then be able to continue, and then I'll let them continue until they flame out. Seems simple enough. Looking at this, speeds staying constant, altitude is increasing very, very slowly. So the question becomes, does this have enough thrust when fully loaded? I am tempted to dump out some of the oxidizer. So, I mean, we're down 500 units of liquid fuel already, so that equates to, what, 600 units of oxidizer? Something like that. So, what we don't want to have is basically leftover oxidizer. So that's just weight that was shifted into orbit that we can't actually use. And I also realise we don't have docking ports on this, which is something that I'm going to have to add. But do that later. I'll probably add a docking port here. Seems a logical place for it on this. Okay, so yeah, I'm going to dump out a little bit of oxidizer, thanks to tack fuel balancer. Which way are the fins pointing? Yeah. Dump touch out of the nose. Now dropping the oxidizer is going to lighten us up and we should be able to climb faster and accelerate, which you should be able to see on screen. So we're going to drop it to 6,400. I'm going to drop it nice and steady. We are of course watching the control fins at the back, these ones, making sure they don't start going too far in their range to hold the nose, because that would then indicate something's going aerodynamically wrong, or at least the weight distribution is screwed. That's 6,400, and we're looking okay on them. Let's have a look at liquid fuel. I'm not going to hit the balance just yet. Still struggling a bit, so let's go ahead, dump some more, drop it to about 6,000. That should help. I haven't even attempted to do a high altitude flight with this yet. As I said on previous videos, I'm videoing the tests for this thing. Basically as a treat to all the people that watch my videos. Unfortunately, I've saved this one till last because I know full well it's going to be the most boring. Why is it the most boring? Because getting the Squished Frog Mark IV Model B into orbit took pretty much 2 days of constant tweaking to get it up there. Oops, and we've gone a little bit too far on the oxidizer, but never mind. So climb rates come up. Forward speed is slowly coming up, which is not a good thing. So let's go ahead and put us back on the 90 and drop our nose by up, please. That was weird. Why did you want to pitch the nose down? Anyway. I have to be careful of that. Anyway, as I was saying, yeah. Pitch the nose down, which will increase our forward speed, hopefully. Without dropping too much altitude, which it doesn't seem to be increasing our forward speed. In fact, it's slowing down. That's weird. Why are you slowing down? Okay, let's go ahead and raise our nose back up again. I think we're definitely underpowered here. Right, let's go ahead and dump some more oxidizer out. Once I find out the level of oxidizer that we're actually going to use in relation of liquid fuel, i.e. how much liquid fuel we're going to use to get up to the point where we start using the Rapier engines in rocket mode, then I can either whack on a few more fuel tanks or just not start off with that much oxidizer in the first place. Like 55% on the forward tank, that should be enough for the time being. Well, the good news is the speed's picking up a bit more lively now. Altitude's still slowly going up. Definitely don't like the angle of attack here. That seems way too high. Angle of attack is basically governed by the amount of lift that the wings have produced and the forward speed. So that would indicate we don't have enough wing surface area, which could be a problem here. Let's take a look from the main cockpit. Not a bad view, but not a lot to see at the moment. Just stick your head down and look at your feet. It's also fitting that Jebediah is doing this rather experimental test. One tip I will give you when you're doing testing like this is to have plenty of coffee on hand. Coffee is what all Kerbal nauts drink when they're testing. Nice, strong, hot coffee. You just can't beat it. Speed's still rising, still climbing at the same rate. Tail fins, yeah, they're still pointing down. So it's still, the nose is, according to the aerodynamics, the nose is still heavy. Yeah. There is a huge problem with this. We should start speeding up quite spectacularly, surely. We should be getting out of this thick, heavy bit into the lighter bits. The biggest issue with this design and the Mark IV Squish Frog was that the centre of thrust was not in line with the centre of weight, and the centre of lift was not in line with the centre of weight. And this one, the centres are absolutely ridiculous in terms of alignment. So your biggest problem with getting into orbit was having to shift the weight around. Now with the squished frog, it wasn't too bad because you had the Rapier engine slung underneath, so its centre of thrust was closer to the centre of weight and the centre of lift. But I say that I may need to swap the engines round on this bus, because at the moment you've got all of the turbofans in the centre, which puts the centre of thrust from the turbofans closer to the centre of mass and the centre of lift. Because of where I've got the Rapiers, their centre of thrust is closer to the centre of mass and the centre of lift. So combined in atmospheric flight, they're within tolerance. However, gliding is a pain because you don't have a centre of thrust, obviously. And the centre of mass is on this way, way, way above the centre of lift. In terms of above, I mean that way. The centre of mass on this is right around about where my cursor is. Let's go from a proper side view here. Right around about where my centre of my cursor is. It's slightly behind this centre SAS torque module because of the engines. So it's around about there, just right on top of the tank. Excuse me. The centre of thrust from all four combined is right around about there, pointing forwards. Right, literally right between the two, so it's slightly above the centre of mass, which is fine. You can cope with that. With the amount of control surfaces we've got on here, you can cope with it. But the centre of lift is around about there. If you take that edge there, it's forward or backwards? Forwards. Slightly forwards, more or less at the centre, where it's supposed to be, but it's right on the deck. It's on the top surface of these wings. So it's way below. And the thing is, what isn't shown in the VAB or spaceplane hangar is the centre of drag either. You would have thought it would have been. So, without any thrust, the drag is along this bottom side. Which is why... no, it isn't. It's along the top side. No. Because these modules here produce 1.5 tons of drag, and there's hardly any drag underneath, which is why I've tried to mount these air intakes underneath to increase the drag. So the centre of thrust offsets the centre of drag. Wonderful. Except for when you are gliding or re-entering, in which case it will want to flip the nose up and over, which is a problem that I had previously, for those of you that have been watching my videos. So that is something that you really have to be careful of. The interesting thing that I've found is I did get up to 12,000, pretty much where we are now, doing a straight vertical ascent, and basically ended up putting it into sort of a flat spin and spinning it around, and it wouldn't respond. But then below about 4,000 I started getting a response again from the control surfaces, slowing down the rotation, and pulled out with about 100 meters to spare. So, yeah, I mean, I really was kind of pulling that. I was just on the edge of the nose flipping out. If your angle of attack is too high, so you've got your nose too high in relative to where you're actually flying, it will flip the nose back again and over the top. And it will also like to fly backwards. So that's something you've got to bear in mind when you're designing these weird and wonderful contraptions. Now, if you analyse this as far as a off-road buggy goes, you'll find it's actually quite good. It's got a wide wheelbase, and relatively speaking, the centre of mass is quite low compared to its wheelbase, which is a good thing. You like that. It's an off-roader. It needs a wide wheelbase and a low centre of mass. Yeah, you don't want to know how many times I've killed Jebediah. You know, I compare Jebediah to Captain Scarlet from the Mysterons. Not from the Mysterons. Oh, nuts. That's embarrassing. Anyway, he likes to drive backwards. I know that much. Kind of fitting, really, for KSP. Anyway, yeah, indestructible is my point. Right, we have an excess of oxidizer again, so let's go and dump some more out. Okay, I'm watching what the nose is doing, and right now I'm not liking the result. I may hit the auto balance here. Yeah, it does look a little bit like the shuttle, just weird. The other fun thing is, once I realise how much oxidizer I can actually get rid of, and hopefully get into orbit, then I can just start off with that amount, and then the flight up will be more efficient. He says, touch wood. Oh, stop the dump. Probably also need some more lights on as well. Oh, and another change I did, I just realised while I think about it. You'll notice 2 extra fuel tanks at this end. As I said, the emergency testing video hasn't been uploaded yet, but by the time you watch this it will have done. If you remember on that video, when I ejected the cupola modules, the hitchhiker modules, they did come down slightly nose down, that's the nose. Which then the nose touched down, the parachute's released, and then it slammed the tail down into the ground or into the water. I think, yeah, you guys saw it go into the water. I tried it over ground as well, and it did the same thing. So I added 2 more parachutes to the nose to counteract the extra weight. So hopefully it won't come down at quite such an angle, or touch wood, it comes down level, he says. Coffee. Intake air's dropping. Oh, nuts. And now it wants to fly. Let's go ahead and flip it around like this. That's better, I think. Yeah, that's better. Oh, whoa, what are you doing? Okay, it's just wanting to flip right out. Speed up the fuel balancer. Nope, still flipping back out. Transfer into the nose. And that's just made it worse. Okay, transferring out of the nose. Yeah, that's not good. Can we save this? Looks like yes, we can. Uh-oh. Crap. No, 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 no. Phew. So, perhaps this won't be the last test I show you then. Okay, so what did we learn from that test? Other than to keep our eye on the air intake. It's underpowered, and well, for the amount of wing surface that it's got, i.e. lift, it's underpowered. So I either need to increase the wing area so it generates more lift, or increase the amount of engines. And I think increasing the engines is going to cause a problem. It's going to produce extra drag. Leave it with me, and I'm sure I'll be back in an hour or so.